Hi, this lesson is for finding the area of a triangle that's not a right triangle. So that we call those oblique triangles. So they're triangles that are definitely have a height that's perpendicular to a base, but it's not just a right triangle. So we're going to get started on that. In an oblique triangle, you do have a height. The height is perpendicular, but in the past, you might have tried to find the height of a right triangle where you have a clear base and you have a clear height, and the base and the height are perpendicular. But now we're trying to find the area of a triangle that's not a right triangle. So I'm going to show you two ways to do that today. The first way to do that is to use law of sines, or to use sine, in order to find the area. So depending on where you are and what information that's given, so most of the time you're going to be given a triangle. And let's say we have triangle A, we have triangle B, we have vertex A, B, and C. You would be given, let's say, one angle, let's say that's 50 degrees, and then you would be given a side and another side. In order to find the area of an oblique triangle, you either have to have three sides, or you're going to have two sides and an angle. Now, you always can use law of the sines and law of the cosines in order to find that third side or that angle. But in order to use law of the sine, or use sine, in order to find the area, you need to have side, angle, side. The formula is, depending on where you are, 1/2 either side BC sine A, 1/2 AB sine C, or 1/2 AC sine B. So in this case, we would be using angle A, this one. So therefore, we would need side B, and then we would need side C, which we have. So we could just use that formula, and we have it. These are some examples, which you're free to pause the screen and check them out. But again, if I have angle A, which is right here, then I have to have the two sides right next to it, surrounding it. So it's like side, angle, side. If I have angle C, like this, I would need to have side A, which is this side, and then side B. Again, side, angle, side. So let's try one. We have triangle ABC. We want to find the area of this non-right triangle. You don't have to find the height, but we just want to find the area of this non-right triangle. So we're going to put in the values that we have. We have little b is 13, so that's going to go here. We have little c, that's 15, which would go here. And we have angle A, which is 71 degrees, which is going to go here. And so therefore, I do have side, angle, side, which means that I can find the area using my sine formula. So you're going to say the area is equal to 1/2. If I have angle A, then this last part would be angle A, sine of angle A, which means the two incoming sides, the two sides inside, would be BC. And all of these are multiplied together. So we are going to go A is equal to area, A being the area, 1/2 side B, which is 13, side C, which is 15, and then sine of angle A, which is sine of 71 degrees. Okay, so I'm going to use the calculator I have here on the side. Please make sure that it's in radians, or excuse me, please make sure it's in degrees. You can check to see if it's in degrees by hitting the mode button. And just look down where it says degree, that should be highlighted. So I'm going to quit out of that. I'm going to type in sine of 71 degrees first and hit enter. And then I'm going to multiply that value by 15. And then I'm going to multiply that value by 13 equals, and then I'm going to divide that by 2, or multiply it by 0.5. And I get 92.19. So this means that the area of this triangle, which is ABC, is equal to 92.19. And depending on the units, there's no units labeled, so we'll just call it units squared. And so that would be my answer to find the area. For this problem, we have HPJ. And so we know little h is 5. We know little p is 7, and I know little j is 11. So for this for this triangle, actually I need an angle. I have 3 sides. So if I'm going to use the sine formula, I have to have at least one angle. So I'm just going to choose H to find that angle. And so therefore I'm going to use law of the cosines first because it's side, side, side. So in order for side, 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 you have to use law of the cosines. So we're going to say H squared is equal to P squared plus J squared minus 2 times P times J, and then cosine of H. So now I'm going to plug in the numbers. So H squared, little h squared, is 25. So I'm going to go 5 squared equals P squared, which is 7 squared, plus J squared, which is 11 squared, minus 2 times 7 times 11 times cosine of H. I still don't have H. So in order to isolate the H, solve for that, I have to move everything over to the left side. So we're going to start off with 25, which is 5 squared. And so what I'm going to be doing is basically I'm taking 5 squared, I'm subtracting 7 squared, I'm subtracting 11 squared. And then what this is right here is 2 times 7 times 11. And so I'm going to be dividing by that value once I have this left side. So on the left, I'm going to go 25, subtract 7 squared, which is 49, subtract 11 squared, which is 121, and that equals negative 145. So on the left-hand side, I have negative 145, and that equals this value here. So on the left side, again, on my calculator, I'm going to find 2 times 7 times 11, and that gives me 154. But remember that on this that this is negative. So this is negative 154. So negative 154, and this is cosine of H. So now I do have to divide by negative 154 on both sides to find the angle. And so I'm going to say negative divided by negative is positive. So I'm not going to bother with the negative signs. I am going to go 145 divided by 154, and I get 0.9416. So this is going to be 0.9416 is about cosine of H. And again, remember I'm trying to get H so that I can find the area. So H is equal to arc cosine of 0.9416. And remember to check to make sure that this value is within our range. Meaning they're asking me, where is cosine, right? There's my cosine wave. Where is cosine 0.9? So it's like right here, very, very close to 1. So it's this value right here. That's the angle that I'm looking for. And so I'm going to take on my calculator, I'm going to go second cosine, that's arc cosine. And I want the whole value because that's going to give me a more accurate answer instead of just rounding to 4 decimal places. So I'm going to say second answer. And what it does is it pulls the answer from above up here so that it gives me a more accurate answer. So it's 19.7 degrees. So H is approximately 19.7 degrees, which I can now put up here. And now I have, let me erase that. Now I have side angle side. And because I have side angle side, right, I have the side, angle, and then the side, now I can use this formula for the area, which is 1/2, right? Oh, let me write area. So I can say area is equal to 1/2, and then I'm going to use both sides. So I'm going to say P and J. So P and J, sine, and the angle, 19.7. So I'm going to plug that in. Oh, but I don't have that value yet. Let me put the values in. So area equals 1/2 P, which is 7, times J, which is 11. And then I've got sine of 19.7, so 19.7 degrees. So we have sine of the answer. Might as well just type that value in, gives you more of an accurate answer. Times 11 equals, I'm going to go times 7 equals, and then I'm going to go divided by 2. And that value is 12.96, so about 13, almost about 13. So my area for this triangle is approximately 13 units squared. All right, cool. Now, remember, they gave us all three sides. So there is a formula, another formula that I told you I would show you two formulas. You've got your sine formula, which is 1/2 BC sine A, that formula. But you also have another formula that's called HERON'S formula. And this is a formula where you can find the area of a triangle if you have all three sides. You absolutely don't have to have any angles. And so the formula says the area is equal to S times S minus A times S minus B times S minus C, where S, just S, is equal to the semi-perimeter. What does that mean? That means I'm going to add the lengths of all the three sides. I'm going to add them up, and I'm going to divide by 2 because it's a semi, it's cut in half. So let's use this formula. Three sides, find the area of the triangle. So first I want to know what the perimeter is. So my perimeter of this triangle is going to be equal to 12 plus 22 plus 16. And so let's see, we've got 12, oops, I'm not going to use it there. So I've got 12 plus 22 plus 16, I get 50. I'm going to divide that by 2 since it's a cut in half because it's a semi-perimeter, and it's 25. So my S value is 25. My perimeter was 50. Okay, so to use this formula, what we're going to do to use this formula is we have to say the area using HERON'S formula is equal to, I'm just going to write it out first, the semi-perimeter times the semi-perimeter minus the first side times the semi-perimeter minus the second side times the semi-perimeter minus the third side. And so that's going to be semi-perimeter being 25. So 25 times 25 minus 22, 25 minus 16, and 25 minus 12. And so what that is, we're just going to plug that in. You can plug that in 20, if you want, or you just type it in. I think it'll just take the whole thing. Let's see here. Second square root. I'm going to go 25 parentheses, so times 25 minus 22, close the parentheses, new parentheses, 25 minus 16, and a lot of you guys can do this in your head, and you should, times 25 minus 12, and you close the parenthesis, and you're done writing that out. Hit enter, and I get 93.7. So my area, therefore, the area of this triangle is going to equal approximately, because we did round, 93.7. I think we're in meters. Yep, meters. So this would be meters squared. Area is always meters and squared. Okay. So remember, just going back, if you ever have to find a side or an angle, you use law of the sines if you have two angles and one side. Law of the cosines if you have two sides or three sides. And of course, the ambiguous case, most of the time we're going to use it with law of the sines. But if you watch the law of the cosines video, I also showed you a way to use the ambiguous case, which is side-side angle, with the law of the cosines and the quadratic formula, which is, I think, a little bit easier. That's all there is to this chapter. So you're going to be finding, or that section, you're going to be finding the area. There's two ways to find it. Again, if you have three sides, you can use HERON'S formula. Or if you have two sides and the included angle, you can use the sine formula. Thanks so much for watching.